For the vector space of all real-valued functions, find a basis for the subspace spanned by the set of vectors. So here we are given a set containing 3 vectors. So we have vector v sub 1, vector v sub 2, vector v sub 3, being defined by vector v1 is sine of t, vector v sub 2 is sine of 2t, and vector v sub 3 is sine of t cos of t. And so to get started here, we want to recall the double angle formula from trigonometry. So the double angle formula. So if we let k be some real number, we recall that sine of 2k theta is equal to 2 times sine of k theta multiplied by cosine of k theta. And so we can actually see the double angle formula here taking place within our set of vectors. We have sine of 2t is equal to 2 times sine of t times cosine of t, which is equivalent to saying vector v sub 2 is equal to 2 times vector v sub 3. Now we want to be careful here in using this form because we can see that vector v sub 3 is a scalar multiple of vector v sub 1. They both contain sine. So to establish that linear dependence relationship here, we want to remove v sub 3. So we can say that since vector v sub 3 is equal to 1/2 times vector v sub 2 plus 0 times vector v sub 1, this shows us that v sub 3 is redundant. And we can remove this vector to create that spanning set. So we can say that by the spanning set theorem, the set defined by vector v1 and vector v2 only will be linearly independent. So this is the set containing sine of t and sine of 2t, still spans the subspace. And to verify that this subset can still be a basis, again, we want to confirm linear independence here. That's why it was important for us to choose vector v1 and v2, because we can see that there are no scalar multiples between the two. So vector v sub 1 does not equal a scalar multiple of vector v sub 2. And so therefore, this subspace is linearly independent. So we have shown that this set containing vector v1 and v2 still spans the subspace, and we've shown that this set of vector v1 and v2 is linearly independent. So we can finally conclude that since both conditions are met, this is a basis for the subspace. So since both conditions are met, the set containing sine of t and sine of 2t is a basis of our subspace. And this is our beautiful final answer.